Hello, calculus students. All right, once again, we have a derivative problem, computation of a derivative problem. Here the function is 1 over x plus 2, and we want to find f prime of x, so we're going to compute the derivative of f of x. So what I'm going to start with here is my limit definition of the derivative. So I write my difference quotient. And then I'm going to plug in x plus h into my function. So what does f of x plus h look like? Well, f of x looks like 1 over something plus 2 minus 1 over something plus 2. In this case, I put in x plus h. And in this case, I just simply put in x. And then I have over h. Now, whenever I have a fraction of a fractions and I'm using the difference quotient, what I like to do, and I recommend this strategy, is instead of making this divide by h, that's the same as multiplying by 1 over h. So I'm going to push the 1 over h there. Just kind of helps me keep these fractions straight. So I have x plus h plus 2 minus 1 over x plus 2. So if you look at this step, you see it's the exact same thing as this step. Dividing by h is the same as multiplying by 1 over h. Okay, now I need a common denominator. I have an x plus h plus 2 here, and I have an x plus 2 there. The only thing that they have in common is their product. So that means I have to multiply the top and bottom of this guy by x plus 2. And this term here, I have to multiply the top and bottom by x plus h plus 2. It's the only thing they have in common. You might be tempted to write plus h here and plus h here. That would not be correct. Okay, so now in the numerator, I have an x plus 2. In the denominator, I have x plus 2 times x plus h plus 2, and I'm just going to leave it like that as a product, because when I evaluate the limit, that h is going to go to 0. And of course, I have the common denominator here. So I'm anticipating letting that h go to 0. Okay, and in this term, I have x plus h plus 2. Okay, well now that they have a common denominator, I can deal with this numerator. So I'm going to put them over their common denominator of x plus 2 times x plus h plus 2. And then I have an x plus 2. Now this minus sign is going to get distributed amongst all these terms. Minus x, minus h, minus 2. Then you look, oh, the x's cancel, and the 2's cancel. So that leaves me with that minus h on the top. Over h, minus h on the top, x plus 2, x plus h plus 2, and okay, the h's cancel. Now the h goes into h one time, so I have a minus 1 on the top. So now I will just simply rewrite what I had. I have a minus 1 on the top now, an x plus 2, an x plus h plus 2, and I just evaluate this limit now. I let h go to 0. So I have x plus 2, x plus 0 plus 2. Now I simplify. Minus 1 over x plus 2 times x plus 2. And so that is minus 1 over x plus 2 quantity squared. And that's what f primed of x is. So just to recap, start with your difference quotient, plug in x plus h minus x here. So f of x plus h minus f of x, sorry. And then my strategy here is if I have a fraction of fractions, I move the h over and I make it a 1 over h instead of dividing by h. Then I find a common denominator. So in this case, the common denominator is the product of the two denominators. So I can't change the value, so I have to multiply this by 1. It's x plus 2 over x plus 2. X plus h plus 2 over x plus h plus 2. Now that I have a common denominator, I just multiply 1 times that term, 1 times that term. Then I put them over the common denominator. I distribute the minus sign to all the terms, and I do my cancellation. H goes into h one time, leaving me with minus 1. So I'm left with minus 1 over the denominator. I let h go to 0. I have minus 1 over x plus 2 times x plus 2, and that's minus 1 over x plus 2 quantity squared. Okay, good luck.